Okay, so we're talking about section 2.6, which is compositions of functions. So here's our definition of composition of functions. If f and g are both functions, then the composite function or composition of g and f is g composed with f of x equals g of f of x. So pay attention to the notation. I've mentioned that a few times the past couple classes. Pay attention to what this function notation is telling you. So I've got a little diagram over here to the right. So I've got two functions. I've got one of them in red is the f function, and in G is the green function. It's a little box. And so you can think about this little box. We're putting in some input, in this case x, right? It goes into your function f, and then it comes out the other end. That's your output. So if we go back to this particular notation, we're saying that the x is our initial input, right? So we take that x and we put it through the function f of x, right? So you drop the input, the number, into f, right? It does some calculations on it, and it comes out with its output, the y value, or in case the value of the function, so f of x. So what happens in a composed function is we take that value, whatever the value of f of x is, and we plug it in to g of x. And then we do the calculations on g of x, and we come through, and that output is the composed function, right? G composed with f of x. That's it. So it seems a little bit strange, but really once you get used to it, follow the notation. It'll tell you exactly what you're supposed to do. This notation here will tell you exactly what you're supposed to do. So I've got two functions below here. We've got f of x equals, I'll leave that so we can see. We've got f of x equals 4x plus 1. And we've got g of x is equal to 2x squared plus 5x. So I'm asking to find g composed with f of x. So let's do that. We're going to follow this definition we have up above. So we're looking for g of f of x. So I'm going to put, that's what we want to evaluate. So what does that mean? What does that function tell us? What does that notation tell us to do? It tells us to take this expression for f of x, and in the function g, wherever there's an x, we're going to replace it with f of x. So I'm going to do a few things here. So let's rewrite this like this. G of, and f of x, that's our function 4x plus 1. So we've got to evaluate that. And so in the function g, wherever there's an x, we're going to replace it with this expression 4x plus 1. So we've got 2, and instead of x squared, we're going to have that expression squared, plus 5 times, instead of x, is going to be 5 times the f of x that's in there. So wherever there was an x, here where there was an x squared, we're going to have 4x plus 1. That's the function f squared. Plus, and then instead of 5 times x, it's going to be 5 times the function f, which is 4x plus 1. The rest of it is sort of simplification, right? It's going to be 2 times, remember you're going to have to FOIL this 4x plus 1, so it's going to end up being 16x squared plus 8x plus 1, that whole thing is still in parentheses because we still have that 2 out front, plus I'm going to distribute the 5 since I can to both of these, so that's going to be 20x, and this 5 gets distributed. 5 times 4x is 20x, and then 5 times 1 is plus 5. Okay, so I got to distribute the 2 now, so you get 32x squared plus 16x plus 2 plus 20x plus 5. Collect some like terms, so we get 32x squared plus 36x plus 7. So that's our composed function. Okay, so we calculated what the function would be, the composed function, g composed with f of x would be. We know it's 32x squared plus 36x plus 7. But let's use this. We've got this new composed function. Let's evaluate this function at -1. Right? So I want to do it first using that little diagram where we have these little function machines. And so you can see what happens over here and compare it to with what happens on the left. The value should come out the same both ways that we do it. So let's get started. So we're composing g composed with f and evaluating at -1. So we're plugging x equals -1. That's the value that we're throwing in. That's our input into this function f of x. So f of x is 4x plus 1. So when you calculate that with x being -1, we're going to get 4 times -1, which is -4, plus 1. And so we're going to end up with a -3 for that, right? So we're going to take that value, right, and drop that value into our function. So that -3 is f of x. We're going to take that value, we're going to drop that into the outermost function, the g function, which is 2x squared plus 5x. So when you plug in -3 in for x, we're going to get -3 squared is 9 times 2 is 18 plus 5 times -3 is -15. So we're going to end up with 18 plus -15. That's going to be 3. So g composed with f of x should equal 3. So let's do that same calculation, right? Let's do that same calculation over here, except we're going to use the function that we calculated just a couple minutes ago. Alright, so if we want to evaluate g composed with f of -1, and again, just let the notation work for you, we're going to replace the x with -1 in this function, so we're going to get 32 times -1 squared plus 36 times -1 plus 7. And so -1 squared is +1 times 32 is 32 minus 36 plus 7. And guess what we get? 32 minus 36 is -4 plus 7 is 3. Right? That's what's happening. You're coming up with a new function that's composing those two things, but that's exactly what's happening for that. Okay, so get some practice. Like any of these things, get some practice. It's not too difficult, but you really want to understand what's going on in these composed functions because they're going to be really useful.